Okay, so in this video, let's work through problem number 4 here. And this is another type of solution stoichiometry. It's very similar to the titration reactions that we've done in class and in the laboratory. And as I run through and look at the information, right, what I like to do is sort of use the space below, right? I want to know the molarity of the base. And I've added 18 milliliters of the base. And it neutralizes a certain volume and concentration of the acid. So let's put that information here. And then just to give you the typical layout, right? The information, right? You're always going toward the unknown. And then the first question is, how do I use this to calculate moles? Well, we learned in a previous example and examples from the class that moles is equal to the molarity times the volume in liters. Let's go ahead and convert these to liters, right? You're basically going to divide by 1,000 here. 3, that pushes the decimal over 3 places in each one of these. So let's just go ahead and do that. And I think I'm just going to set this up as a single equation down here for this calculation. So the first step, let's take our concentration and volume of the acid. We're going to multiply the two together. And just like I've done in previous problems, instead of writing out the capital M, let me actually break that apart and represent it using sort of its base units, if you will. And what we can do is we can then sort of use this to follow the unit cancellation here. And what I mean by that is that, right, since I'm multiplying the two together, the liters are going to cancel out. I'm left with the moles of the acid. And then once I have mole value, then I can use my molar coefficients to then convert from one mole to another mole. Since I'm dealing with moles of acid here, then it's the 3 moles of the acid that's going to go on the bottom. So I'm going to divide by 3 in this step. And then the 2 moles of the base will go on top. So also, and I'm going to multiply by 2. And if I pause for a minute and consider the units here, so this is the moles of the acid. That cancels out with the moles of the acid, right? And then in my last step, what do I want? Well, I want to calculate the number of, well, the concentration, molarity. Molarity is moles divided by liters. One way to show that is to do this. So my moles up top here to divide by liters. And then I can just keep that sort of same structure of the parentheses, making sure I factor in that the movement of the decimal. So moles divided by liters is going to give me molarity. So if I do this entire calculation, right, 0.2544, times that volume times 2 divided by 3 divided by the 0.018. Then my calculator gives me, well, let's see. I've actually rounded it off to the proper number of sig figs in my notes. I'll just stick with that. Why did I use 3 sig figs here? Well, if I look at all my data, right, the rule is, however, the fewest number of sig figs in my problem determines the number of sig figs I'm going to use in my answer. So I had, there's 4 sig figs in the 0.2544, 3 there, and 3 there. So 3 is the lowest number, so I'm keeping 3 sig figs in my final answer. And that's it. Okay, thanks.